let us take y to be a raised to the power 7 x raised to the power 4 plus 2. And the question is to find the derivative of y with respect to x. Without wasting time going through the rigors, we can simply substitute here and then we get the result. But for the purpose of deeper understanding of how we got this, let's resume the proof from the beginning and then we arrive at what we're going to have there. So we take the logarithm of both sides to base e and have log to base e of y is log to base e of a raised to the power 7x raised to the power 4 plus 2. Which is the same as 7x to the power 4 plus 2, then log to base e of a. Again, when we differentiate both sides, we have 1 over y dy by dx on the left hand side is equal to differentiating this right hand side, applying the product rule. We will differentiate this, keep this constant, plus we keep this constant, so we keep this constant and differentiate this. That's the product rule. So if we differentiate this, keeping this constant, then we're going to have 14, 7 times 4 is 28. 28 x, all right, 28 x raised to the power 3 multiplied by log of a to base e plus we keep this constant and differentiate this, we get 0. So this is 0. And this returns 28x raised to the power 3 log to base e of a. So now dy by dx alone, dy by dx alone is nothing but y times 28x raised to the power 3 log of a to base e, which we can rewrite as 28x raised to the power 3, who is y, so I can have here y log a to base e, which is nothing but 28x raised to the power 3. Our y is this person, so we have a raised to the power 7x raised to the power 4 plus 2, then log to base e of a. This is the result of differentiating y with respect to x. And then this is all about differentiating exponential functions. I wish to say a few things about what we have been doing. If you have been following the videos in the channel, you will see that we are sequentially treating the steps or the topics, the concepts rather, involved in calculus. And we are very much elementary, bearing in mind our audience who are precisely first year undergraduate students. Some are math majors, some are people from engineering, physics, education, who are taking this course. And many of them are not familiar with calculus for the first time. So this is the first time they are meeting calculus in their life. So we are as simple and elementary as we can to ensure that everybody is carried along. There are some details that we have not given for each of them, which we feel are a little bit advanced. We shall deal with that in the channel later on, so that those math majors will enjoy those concepts when we put them on the channel. But for the time being, notice the sequence we are following. Each topic we treat here is a topic you can find in any standard book in calculus. And it is also the topics that are required for a first semester course, a one semester course rather, in calculus. So if you can follow the things we're doing in the channel very well, I know, I'm talking to my students right now, then you're sure that you are getting well trained in calculus. So that's all about this. Next, we shall look at how to differentiate the inverse of trigonometric functions, hyperbolic functions, before we now get into application of differentiation. We apply them in many places. We'll take some examples to see how we can apply them. All right.